Hey guys, welcome to this live stream. If you guys are watching this live right now, or if you guys are watching this video later, as you can see on the corner of this video, today we're building this humanoid robot. It's an open source robot by UC Berkeley, and we have all the various components arranged over here. There's a bunch of hardware stuff. We have some encoders, we have microcontrollers, and a bunch of stuff, and also all the parts for the robot that needed to be 3D printed. We have 3D printed them as well. We have pretty much everything ready to go. These components, we have arranged them all. They were really expensive, and some of them are still not shipped yet. There's like another topic, how long it takes for the parts to ship worldwide. Like this. But we're gonna be working with the components we have right now. We 3D printed the actuator parts as well. Many of them. There's actually 22 actuators in total. But this mechanical aspect, we're gonna come back to this a bit later. For now, we have some electronics related stuff to take care of. Yeah, so if you look at the corner screen once again to the robot that we're going to be building, it has a lot of actuators. The image is really small, you won't be able to see it, but all the joints of the robot are made of these actuators. So these are the parts that give the robot those degrees of freedom to move around, to pick up stuff, do stuff. So one really cool important component we have to show you yet is this. So these are the motors that have arrived, and this is what we're going to be fitting in these actuators. It's going to be really interesting, and we're going to be documenting this whole process. We're going to be recording everything, and you're going to get to see this robot being built live with us. So yeah, this is there's a lot of other hardware stuff as well lying around, but we're gonna move to the hardware section later, like I told you. Today we're gonna be dealing mostly with the encoders. So what we're gonna be doing today is a bunch of soldering, especially this SMD soldering. So let me try and zoom in on this encoder over here. So we're going to be working with a lot of these. There are 22 of these encoders in total in this robot. We have all of them over here. And what we need to do with these encoders, let me try to point it out for you guys. So we're going to be removing these two resistors, and then one of this resistor, instead of it being in this direction, we're gonna attach it with this direction pin over here. So we're gonna attach this. It's a 0 ohm resistor, so it really does not do much, but we're gonna be soldering it between this R1 and DIR pin, and we're gonna be doing this for 22 encoders today. The soldering station, it's a bit of a mess, as you can say. It's not exactly SMD soldering components, but we're gonna make use of what we components we have available. So we're gonna be doing it with two solders. They're both live right now. I know this is not the most efficient setup, but we're gonna be using this to achieve this. So yeah, let's start. This is we already. Let me actually show you what it looks like once we're done doing what we're trying to do over here. So if the camera can focus on this encoder, as you can see, we have removed the bottom resistor over here, and this resistor, we have changed the orientation of this resistor like this. So yeah, that's what we're gonna be doing with the all the other encoders. That's the first step. There are after that we're gonna be attaching wires. We're gonna be attaching this encoder to the motor controllers, and this is the first step. So let's place the first encoder over here. This is the second encoder, and we're gonna be removing the resistors from it now. Yeah, itadakimasu. So one thing about this SMD, if soldering and desoldering, is if you've never tried it before, it's really difficult to remove this component if you just try to remove it by using solder. So if I just try and push this, no matter how much heat, I mean, to a certain extent, like this is a 20-watt soldering iron. So if I try to attach it to both of these sides, try to heat it up and try to move it, it's not gonna work. So in SMD components, in order to remove this component, what we need to do is we need to add a little bit of solder on both of these sides. So I'm gonna attach a little bit over here, and I'm gonna do the same on the other side. Okay, now if you guys can see it, now I have added a bit of solder flux on both sides of the resistor. This is a much better conductor of heat. If we were to just apply the soldering iron on both of these sides, it was not gonna be as much efficient. But now you're gonna see what happens when I attach soldering iron on both of these sides. The part is this part is gonna move on its own. It's just gonna leave its place. So I have both. I know this looks really sick, but this is not the right way to do it. But we're gonna do this way anyways. So now I'm gonna start applying heat on both of these joints, and as you can see, the component just moved on its own. Let me place this back, and let me remove this thing. So here you can see this is the resistor. If I can place it on my, yeah, if the camera can zoom in on it, it's really small. Yep, now it's lost focus again. Yeah, now you can see this. Look how small this thing is. This is next to my nail. This is the resistor we just removed, and we have to apply it back in a different direction. But now what we're left with over here is we're left with a bunch of this messy solder on both of these pads. We want to remove this, and for this we're gonna be using this thing over here. I'm gonna heat it up and I'm gonna apply it onto these pads, and it's gonna absorb all the excess solder in it. So as you can see, I've worked a bit with this before. This is all the absorbed solder. So we're gonna be using this to remove these remaining soldering parts. So I'm gonna apply place it back. I've just attached a double side tape on the table, and that's what I'm using. This is not a soldering station. This is just a quick soldering solution I've made to do this, but you obviously need a more efficient soldering solution than this. So I'm just gonna place this over here, and we're just gonna apply a little bit heat. I think our voice is not that clear in this live stream. Can we bring that mic over here? Let me try and do that. Okay, if there were any issues with the voice before, now it should be fixed. Now it should be much more clear. There is here. Yeah. So we also need to remove this bottom resistor as well. So I'm gonna do the same. I'm gonna apply this soldering flux paste on both of these sides. Add a little bit over here. So to solder these SMD components, they have these really cool setups with magnifying glass. It's really easy to see these small components, and it's really easy to get in there and apply that soldering iron efficiently right where it's needed. But right now I'm just doing it with the naked eye. It's there are smaller components than this, and of course we won't be able to do that like this by using only our naked eye. Yeah, here's the 0 1. Okay, let's apply heat on both of these sides, and it has started to move. We have grabbed this, and once again, if
It's
you're able to see
small.
how
Here it is. If you can see, this is the resistor.
yeah, it's just a speck on the table.
Right, I'm gonna pick it up, check it once, and then we're gonna place it here inside of this table, inside of this bucket. Small. Yes, the value is 102. Alright, once again, if I can try to showcase it over here, if the camera can focus, this is the resistor, and this one is not needed, so we're just gonna place it inside of the bucket here. Alright, and this one we need to resolder once again, so we'll just place it here for now and make preparations. Yeah, right here, this is the one.
So first I'm gonna clean up this pad over here so it looks nice. Okay, almost done with it. Okay, now that we have those pads nice and cleaned up, let me zoom in a bit. Let me bring it closer to the camera.
I'll cut this part.
Yeah.
Just good absorption.
Okay, so now you can see we have removed the resistors, and it's really clean. These sections are really clean. Now what we're gonna do is I'm gonna start by applying a little bit of solder to here, to this part, and then to the direction pin, and then we're gonna pick up this small speck and we're gonna place it just like we did over here on this encoder. So yep, itadakimasu. I'm gonna take this. Okay, now what we're gonna be doing is we're gonna pick this resistor and first I'm gonna attach it on one side, and once it kind of locks in place we can just leave it, so it's not gonna move around. This place is gonna stay still, and after this I'm gonna kind of
solder the other place nicely. Okay, let's have a look. Let's see if the camera can focus on here. Yeah, there's a bit of excess solder paste over here, and it's not like perfectly.
I don't think the focus is good. Yeah, now it's better.
Yeah, and it's not exactly horizontal. So let me try and fix that. I'm gonna hold it in hand like this, and we're gonna try to melt this side, and we're gonna take off the excess solder from this area. And we're gonna make it sit nicely there. Let me take it away from the camera and have a look at it. Yep, I think it looks okay. It's not placed like perfectly horizontal, but both the ends are shorted.
Maybe on the left side you can apply a bit of pressure from the top so the resistor sits down horizontally. Maybe.
I think this is good enough.
If the connection, if we can test from continuity test, like
Yeah. Let's try and do a continuity test. If yeah.
all good.
Yep.
Fun. Two down.
Yep. The connections are good. So both sides are shorted together. I don't need to. I mean, we can apply some force and make it sit horizontally, but both connections are
They're pretty solid, yeah.
Yeah. So the second one is down. Let's bring in the next one.
20 more to go.
Yep, 20 more to go. So this, all of them, they also have the small magnet in them. All of these came in with these magnets. We're gonna look at these. This is a small magnet. We're gonna look at these components later on. So I'm gonna place it just over here with the rest of the stuff, and let's try and remove both of these at the same time this time around. So I'm gonna apply some solder over here on the both the joints, and same for the bottom one. Okay.
This is the opposite to R1, right?
Yeah.
Okay.
R1 and R4. First, let's just remove the R4 and place it in this bucket over here. After placing it in the bucket, I'm gonna try and zoom in and show you the resistors in here. They're like really tiny. Okay, I'm gonna try to move it now. Okay, you can grab it. Okay, just throw it in this bucket now, because we don't need it anymore. And
this one.
remove this one now. Okay. Let's clean up the area. To apply the solder again, I'm gonna alright, so let's there's a little more flux over here and here. Now we're gonna try and put this here. So yeah, you can just place it in the correct orientation, and I'm gonna make join one and this bottom, and let's try this one first. Just a moment. Okay. It's a really precise job. Yeah, so this,
So like
as you can see, the bottom end we have attached it successfully, and I'm gonna try to now bring this solder, this soldering paste to this end.
yeah, I think this one came out pretty nice.
Yeah. Is this? Yep. It's sitting perfectly there on its place. So this is what the encoder looks like. We need to make this diagonal sort of connection. Let me do a continuity test on this to make sure there is no shortage going on over here. This connection is good, and it's not short with this bottom part over here. This needs to be short. This is all good, and there's no shortage over here.
Nice.
Okay, the third one is done.
3 down.
Let's move on to the next one. And all of these encoders came in with these magnets, like I've told you, and we're gonna later on, it's probably gonna be the next live stream, we're gonna attach it to the motor encoders, and the motor encoders, we're gonna attach those to the motor drivers.
Yeah, we're waiting on the parts still. Logistics and supply chain is a huge delay. It just kills all the momentum. And we'll probably have the parts by tomorrow or the day after tomorrow, we're not sure.
Most probably by the day after tomorrow, we'll definitely have them. But meanwhile, we're gonna be attaching wires to these encoders, getting them ready to be attached to the motor controllers. We're also waiting on some hardware stuff, like brass inserts, some screws,
Bearings.
yeah, and once all that stuff arrives, we're gonna be able to make the encoders work on those actuators that we showed earlier in the live stream. So those actuators, they need some hardware components. we don't have all of them yet. We do have a few to make 4 or 5 actuators, but we don't have everything available at the moment. Right, I'll just be careful, be careful. I'll just grab this one quick. Yep. Which one is this? It's 102. 102. It's 102
yeah.
is like that.
Just-
This one
just
just
drop it in there.
needs to go in there. Just here. Right, now this
And
one.
let's remove this one as well. Once again, the global shipping, it kind of never recovered after COVID. It's still a mess, but it's these days you can get mostly anything from China if it's available there in the markets, uh, and a lot of times the prices are really cheap as well, and you can get parts from China usually within a week, I'd say. But sometimes when you're in Tokyo, sometimes when you order parts from America, it really depends on the route you're taking or the exact shipping company you're using, DHL or something like that. And sometimes it takes a long time for parts to arrive here in Tokyo. If you're working on some sort of hardware or electronics projects, I'd be interested in hearing your thoughts on the shipping and supply chains on the components, because it's really difficult these days to find all the components you need for an open source project, or even for a particular project if you are using online resources, open source models from the internet. If someone else, let's say living in America, has made some models according to their specification standardizations, it's really difficult to find everything in one place, of course. So I'd be interested in hearing you guys' experience with supply chains, mm, arranging components if they're not available in your country. Yeah, we're gonna let it sit for a bit. We're gonna let it dry, and then we're gonna apply the rest of the solder, because it kind of started leaking at the from the bottom side, as you can see over here. So now
Oh,
it has now solidified.
interesting.
And once it has solidified, we can add the rest of the solder over here. Okay, a bit over here. And now let's try to place our SMD resistor here.
Yeah. Alright, this is gonna be a bit.
It just disappeared. And ladies and gents, that's the trouble when dealing with SMD microcontrollers. They're like so tiny, even if you apply a slight jerk to them, or especially if you're like trying to pick them up using tweezers and they just fly away, it's a really tough job finding them. But here I have found it, and let me try and show it to you once again how small this is. Like, this is what I was looking for, and it's really small. If it's on the ground, it just appears like a speck of dust or something like that. It's really hard to differentiate this from the other specks of dust or small components lying around. So yeah, let's try and solder it in its rightful location.
Let me grab this correctly. Right. like here, and the position is something like this.
Yeah.
Okay. All right.
Another one bites the dust.
Yeah.
Yep, looks perfect to me.
Yeah, just do a quick continuity check on this one as well.
We're gonna do it on all of them together at the
All right,
end.
let's just keep going with all of them, and
Yeah.
after that, once these are done, we'll just quickly move on to removing the supports and making the actuators ready for wiring and
Yep.
bearings as well.
Yep, you guys are. It's your lucky day. You guys are gonna get to see some hardware stuff as well. Let's.
Mostly, it's just gonna be removing supports from 3D printed
Yeah.
parts. Yeah, there's a lot of parts.
Yeah, it's part of the
Lot of
process.
parts. And I thought initially this removing the resistors is going to take a lot of time, but I don't think it will take us more than like an hour. I think we'll almost in an 1 hour or 1.5 hour, all of these will be done. In fact, I think if we had the bearings and the brass inserts, we would have we might have had all 22 actuators ready by tomorrow in just
yeah, but by
one
tomorrow if we get the brass inserts by tomorrow, we're gonna have an actuator working and ready to go. In the next live stream, probably we're gonna have working actuators. Let's grab this component. I'm gonna move.
Right. This tiny little component, if you can see.
Yeah.
Teeny tiny little component.
Let's put it in here.
I'll just place it.
Let me try and show it to you guys how small these components are. They're like small mites, you can say, but these are the SMD components that are present on your
Termites, small termites.
Yeah, small termites that live within your laptops, PCs, mobile phones. These are the components powering your circuits. Not like powering your circuits, but they're like in there. You get what I mean?
Let's just remove the second one.
We're gonna remove the second one now.
And this one, of course, is needed, so we'll just place it over here.
Yeah. So once again, for those of you guys that are joining us just now, we're building this humanoid robot that we have attached a picture along with this video. If you guys are making this robot, what kind of tasks would you ask this robot to do? I'm interested to hear the use cases for this robot or what you guys have in mind, because Tesla is really Elon Musk and Tesla, they're leaning really hard in this humanoid robot direction. I wonder what the use cases are gonna be, because AI space is also moving really fast. We've uploaded quite a few videos on generative AI, some LLMs. We have some open source LLMs as well that you can run totally locally. So if we attach those LLMs in those robots, we give them the capability to improve themselves. To, let's say you're the owner of such a robot and they over time adapt to your personality.
what kind of interesting use cases can we build from these robots? So I have attached the solder over here, these two once again. So it's a little bit more than what we needed, but we're gonna try to place the resistor here. Okay, so like here's the resistor, by the way, this small component over here. Yeah, this speck of dust over here. Yeah, it's like we'll just grab this and I'll take it to its place. If you can turn this a little bit. Okay, yeah, that's just perfect. Over here. All right. Okay. Yep. So we have attached the termite. We've got one of its leg, guys. We're gonna try and grab the other leg now. So let's apply gentle heat over here, and there you go, guys. We've got the other leg as well. The termite is locked and ready. The termite is locked in its place. Okay, there's another one done. Yep. So we're gonna place it over here as well. Is this one? Is this yeah, it always happens with components like this. Okay. Not a big deal. Yeah. This is like unboxing a fresh deck of Pokemon cards, guys. So ASMR unboxing. By the way, this is how much we have left, and we have to go through all of these. Yeah, I bet people clicked on this video expecting something really flashy, a humanoid robot being built and assembled and all of that, and all they're getting to see is just this very precise electronics. Yeah, the final video is gonna be like that though, like the humanoid. Yeah, that was gonna. We're definitely gonna add some big explosions behind the robot, and it's gonna be walking in a really cool style. Yeah, just apply this to both of them first of all. We just after that we'll get them one by one. I would like to hear in comments if you guys, the viewers of this channel, if you guys are interested more in software side or the AI, generative AI and LLMs, because I have uploaded quite a few videos on that topic, and I've also uploaded a lot of videos on quite a few videos on microcontrollers, embedded, the stuff we're doing right now, and building cool robots. Like the Squid Games robot we built just before the season was released. So I'd be interested in knowing what kind of videos you guys are interested in more. We're gonna be building after this humanoid, we have a couple of other robots in mind as well, and we're gonna be documenting that whole process. So if you guys like building cool robots, they don't have to be like full-on crazy humanoid robots. They can be simple like what do you call it, smart plant holders, smart weather monitoring systems, so small gadgets like that. Let me cut this from the front. So yeah, So a lot of cool stuff to look forward to on this channel. But right now, definitely, I would say the most exciting project I'm working on, and it's not that long of a project. It's gonna be finished in less than a week.
Yeah, most likely less than a week. It won't take long.
Yeah, so it's this humanoid robot, and this is definitely the most exciting project we've worked on.
Alright, we wanna resolder this?
Yeah,
This?
let me. It's gonna be a bit difficult to grab this because it's kind of stuck in place. Yeah.
Alright,
So
just
we're
place
gonna-
it.
Let me clean this first.
Oh, here it is. Yeah. Pick this.
Let's grab this.
Be very careful with the soldering though. I mean, the soldering iron is very hot.
Okay. Let's apply a little bit more solder over here. And I'm gonna, if I am able to grab this, honestly in this entire process, that the most difficult thing is grabbing this thing because of how small it is, and if it kind of jumps around from between the tweezers, it's really difficult to find this thing. Let's have a look at it. Looks okay to me from one side. Let's grab the other end and nicely like this. Okay, another one done. 6 out of 22. Let's unbox another one. Da, da, da. You know, a lot of cosplayers are using a lot of electronic components in their masks, and a lot of LED based stuff as well in their cosplay props these days. And here in Japan, I've came across quite a few genius ideas where they've just used microcontrollers to make their cosplays look really cool.
Yeah, and those microcontrollers aren't even big like Arduino Uno or something. Like they're simple small microcontrollers, like small versions of ESP, like this one.
Yeah, this is a really small version of ESP
Yeah, and
S3, ESP32 S3.
S3 or C3? I'm not
This
sure.
one is S3.
Oh, S3.
The
Okay.
C3 is the other one. If you can grab that one, C3.
Oh, this one. Oh,
Yeah.
This is also quite small.
Yeah, so these are a bunch of ESP32 C3s, and this is ESP32 S3, and as you can see, they're like really small and compact, so you can place them in really small robots.
Gadgets or any parts you wanna have for.
So yeah, and I have seen honestly some really amazing genius cosplay ideas from this. If you guys like anime, you know, recently Dan it's a really cool anime, and some people are making glowing masks and
this
stuff
one.
like that.
It's a pretty small 3D printed toy, and it has a display as well. But because the size of the ESP is very small, it can fit very nicely within this, and you can control LEDs or any functionalities you want to control with these.
So let's put them to a side, and yeah, honestly, before these microcontrollers have really made robotics a lot more accessible
for everyone. Before this, you had to there was not a lot of community support surrounding these kind of components. You really had to know assembly language or C hash to program microcontrollers, sometimes down to the gate logic level. But these things, they've made this field really accessible. If you guys love anime, if you guys are interested in anime props and cosplays using microcontrollers, some really cool use cases for microcontrollers in that field, you guys should let me know. There are some really cool project ideas I have in mind regarding anime, and we can make some videos on that. So we have our small resistor termites over here, and yeah, now we're gonna remove this one. First up,
1
let
2
me
3
clean this
4
side over here.
5 6 6 1 2 3 4 5 6. Okay,
There should be one more.
1 2 3 4 5 6. Oh yeah, there's 7 actually. Yeah.
Okay, and let me now clean this part over here.
Be careful with the soldering iron. Okay.
I have seen a lot of here in Japan, a lot of you can call them. I mean, there are some really hardcore otakus over here, and a lot of them are grown-up people that are really into anime, and they make really cool anime inventions with these microcontrollers. So some of them even make anime dolls that have really good motions, that have AI talking functionality. So on the back end, they're using LLMs, custom trained models for that anime character. And the thing I have seen most in Japan is the precision with their inventions. And by precision, I mean even the really small components they are using, they are so high efficiency. And let me try to explain this with an example. We have servo motors over here. So let me grab one and show you a servo motor. So this is a servo motor, okay, and you can control. It's not that precise. You can control the direction of its shaft in 360 degrees. But the thing with this servo motor is the step size is really huge. So let's say if you are building a miniature figure with this, it's gonna be really difficult, and the motion with the servo motor, it's gonna be really bumpy. Like it's not gonna be smooth like this. If there's a lot of load on the servo motor, and let's say you're building a robot and you make the arm of the robot go around, it's not gonna be a smooth motion like this. It's gonna be jerky in steps, dig like this, and that messes up a lot of the motion. Now imagine this is just one joint. In a robot, there are like 26 different axes. Imagine all of those axes are shaking around, and it really messes up the motion of this robot. So what going back to that Japanese thing, what the Japanese people do is they unbox this thing, they pick up the PCB, and they add their own custom resistors, their own capacitors, their own custom modules in there, small active or passive electronic components, to make the motion really smooth. I'm gonna make a tutorial on how to do that. We're gonna try to make this thing act way more smoothly than the stock one that you just grab off of a shelf. We're gonna try and open up its internals, and we're gonna try working on that.
Alright, let's continue with the encoders. And this one still has a bit of soldering
Yeah, it's gonna merge in
Yes.
with the rest of the soldier.
Okay.
Try and place it over here.
All right. Here we go with this one.
Push it down so it sits horizontally. Just a second. Okay.
Good.
I really wish I had a magnifying glass right now. But as you can see, even if you don't have magnifying glass and SMD components, you can do SMD soldering if you're just patient enough. So the really flashy Tesla robots you see in the markets or moving around, this is the process that goes into building those robots. The voice is coming from this microphone is hitting voice from this direction, so it's going to be the loudest from here. Let's try to put it somewhere over here. Yeah. So recently I went to Osaka Expo in Tokyo, and so in that expo they have
Osaka Expo. Osaka Expo.
yeah, from Tokyo,
Oh, okay.
and in Japan, right? So
Yeah.
it was one of the biggest expos in a while. Japan was given this. It takes about 3-4 hours to drive to or to go to Osaka by train, and in this expo they have these pavilions from all around the world. So a lot of countries have pavilions over there. Nepal, Pakistan, India, America, all of these countries. And one of the craziest expos I saw was the Chinese pavilion.
Oh yeah, they had a humanoid robot.
They had a humanoid
like
robot just walking around,
Yeah.
chilling, waving to
Yeah.
the
a huge
attendees.
beefy robot just walking around, and it was really crazy to see.
Yeah, I mean, it
like-
felt so dystopian looking at that thing. It was just waving people casually.
yeah, it's pretty different from when you see it on videos. You don't get the same feeling.
Yeah,
in
that-
real life, it's really something to
Yeah,
see.
that's the feeling I get as well, because we're used to seeing these Tesla robots and these Chinese humanoid robots in videos, but when you look at one in real life, it feels so weird in a way, like the way it moves naturally, and it's kind of like that GPT moment when you first talk to GPT, and if you've never interacted with it before, and the first time the way it gives response to you, of course, if you know how GPT works, if you know what's going on behind, roughly what's the way these LLMs work, it kind of loses its appeal. But if you are ignorant of that fact, and if you don't know how what's going on in the background, it feels really I would say
dystopian.
Yeah,
in a way.
dystopian.
Dystopian in that, especially if you're talking to it for the very first time. But in time, you get desensitized to it. You kind of get used to it. But yeah, that was the feeling we got when we saw the robot there in the expo. It was really crazy thing.
yeah.
Like imagine going to Shenzhen in China and just you casually see robots walking down on the street. It'd be a pretty crazy thing to see.
Yeah, the
This, oh yeah,
the governments are going really. They're really leaning into these uh, totalitarian vibes. Especially the UK government recently has been passing a lot of bills regarding.
which one is this? Let me take a look. This is the 102. So like this one needs to go into the bucket.
It goes in here. Yeah, the UK government has been recently honing in on
Okay.
censorship and also like getting identification from people. So, and all of a sudden it's like moving really fast. The
Okay.
UK has implemented so many censorship laws in the last like few weeks, and an ocean away from there, a little bit away from there, Elon Musk is working on building these humanoid robots. China is working on making these military robotic dogs, and Europe and also a lot of other areas around the world, they're also ramping up these online privacy acts and censorship.
Yeah, I think robotics is kind of having its moment where it's transferring from research stage into commercial. It's not quite commercial yet. Of course, we don't have robots like commercially just walking around or people casually just using or building robots, but we're getting there. There's been an acceleration in the past few years. So the technology is kind of at that point. So like we have the right kind of software, we have the right kind of hardware and 3D printers. So like we can, the hardware is it's quite easy to manufacture things as compared to it was about 10-15 years ago.
Yeah, and also with the AI, it's like strange to see how used to we are with talking with GPT and other LLMs every day these days. Imagine how the next generation will grow up with using these technologies, because it's gonna be like a default. But once again, this is like a really small resistor. Every now and then it dawns upon you how small these components are. But yeah, regarding technology, I was saying it's really amazing. Even if you imagine there were no LLMs like 7-8 years ago, at least LLMs like there are now, and the shocking rate at which they've been progressing, it's gonna be really exciting to see where everything is in a 5 to 10 years time horizon. Because right now robotics and fields like this were really in deep
It's
R
pretty.
and D.
This one's pretty neat, I think.
Yeah, you can have a look at.
Oh yeah, this one's pretty neat.
Let's move on to the next one. Right now, all these robot, especially with the advent of AI, all the growth rate of in this field, especially in robotics, is already starting to ramp up. But with the AI, it's gonna start to get exponential really soon. Yeah, in terms of building this humanoid robot that we're working on right now, this is probably the most dry part, because it's just repetitive soldering and desoldering. But after this, we're gonna be connecting wires, we're gonna be working with motor controllers, and we're gonna make these encoders work as well. So that's gonna be really exciting. In the next live stream, we're gonna be starting to see the motors move.
bring this
once,
here.
once again, let's have a look at the motor that's gonna be inside the.
Yeah, just a moment, and let me.
Yeah, grab one actuator from there and one.
Like this motor is for the M6C12 actuator. It's a slightly bigger actuator.
Yeah. We're gonna fit this motor in this actuator right now. So it's gonna look something like this. It looks really cool. And once again, if you see here on the robot, it's a small picture, but it's all the joints are made up of a bunch of these actuators. Most of them are similar. So the assembly we're gonna be doing it, we're gonna be repeating that for the rest of the actuators. But once we assemble all of these parts, we're gonna be able to see the limbs of the robot move. But yeah, this is we're preparing everything for this, and the ultimate result is gonna look like this over here. It's gonna take about a week for like we literally just started it a few minutes ago when we started
This motor is really amazing, by the way.
Yeah, so we started this project about a few minutes ago. Like showed you, we have been working on the material gathering, the material sourcing for a while now. But regarding working on the robot itself, we don't have all the materials yet. But even at this point, it's gonna take us about a week to assemble everything.
Yeah. MAD actuator. Here. This one also here.
Yeah, I want you to grab this. Okay. Cool. Let's clean it a bit and let's remove this part. Okay, all good. We don't need to clean these anymore. It's okay this way. And I'm gonna add a bit of solder over here. Let's wait for it to dry up because it's little bit of it is on the back side. Let's add a bit of solder over here and now
And you can grab this, and it's here.
yeah, I'm gonna need a little bit more solder on this end. Let's fill this up like this.
By the way, the size of this wire is good. It's 0.8 mm.
Yeah,
So like, yep,
yeah, it works.
pretty small. That one was 0.6 mm, right?
Yeah,
The one that we bought.
Yeah, this one turned out pretty neat as well.
Yeah.
Let's move on to the next one.
Nice. They're coming out pretty good.
Yeah. Okay, these are prepped up and ready to be removed.
Alright,
If you can grab this tweezer.
just a second. This one first of all. Grab this. Careful.
You can just put it in there.
Just a moment.
And let's remove this one as well. Grab this. I think there's gonna be definitely gonna be some issues with the audio. We're gonna have a look at this live stream.
Afterwards.
Look at it. There are three hands in there. It's so funny. Yeah, we're
Looks
gonna.
strange.
Yeah, it looks really strange. Yeah, but we're gonna have a look at the audio stuff later
There's
in
a
the
lot
video.
to do. I mean, we will add in the next live streams. We'll add music as well.
Yeah,
A
we're gonna
subtle
be.
background music. We'll test the audio from this one as well. And yeah, maybe just make the look of the overall table a bit more better.
Yep. Definitely some stuff to work on. But yeah, let's remove this one as well. Is it gonna be raining tomorrow in Tokyo?
Not sure. I can take a look at the weather though. No, it doesn't seem like it.
Yeah, the
gonna
weather
be
recently has been like really cold here in Tokyo. I don't know the weather situation about in other countries because of global warming. In most places, the winters and summers are getting more extreme, but here in Tokyo, it has started to turn cold. It started to feel like December or maybe even January.
I think weather is gonna change a lot in this month, in October. By the end of October, it will be pretty cold. I remember last year, end of October and start of November, it was pretty cold.
Yep. This one is, I think, this is the best one so far, by leaps and bounds.
It's almost perfect, and not
Yeah.
even almost. It's perfect.
What time? It's like 2 a.m. in the morning here where we're working right now. Oh wow, I got it. Let's go.
Yeah. I think you can start handling it on your own now.
Yeah.
So like I can to save some time, I can start removing the supports
Yeah.
from the 3D printed parts.
Yeah. Guys, you know what the craziest thing is? This is my very first time trying SMD soldering. Like I've never done this before. I knew about it, but I've never done it before. So yeah, that's why we were working on this together. Was we don't exactly have the SMD soldering kind of setup in our lab, as you can see. This thing over here, this encoder it's attached to the table by a double-sided tape. So yeah, but I've gotten pretty used to this now. I imagine how much better it would be if we had a magnifying glass and an SMD soldering setup. How much easier it would have been. Yeah, some clips from this live stream are gonna go like really crazy in the soldering space. The the resistor just got attached to my soldering iron and I just had to throw it off using the tweezer. It's a really messy situation, guys, but you don't need a perfect setup to do things like that.
Yeah.
Yeah, so that's the big takeaway from this video. Our soldering station is the most useful component here in our station is this double-sided tape, for God's sake.
Yeah.
So yeah, next time you're feeling you can't really get into this space,
There's really not much one needs.
yeah,
Really not
next
much.
time you're afraid of SMD soldering, just open up this video, have a look at the mess I'm creating over here. This resistor, you can't even see the zero on it. The zero has been removed from the resistor.
Huh?
Congratulations. Yeah, so you can get stuff done even this way. You don't need to have a perfect setup to start. So when you're removing these SMD components, the more this solder wire you attach to both ends of the resistor, the easier it's gonna be to remove by providing heat to the whole module. It's gonna be way easier to remove it if you apply a lot more soldering wire to the setup. Otherwise, you're gonna have to apply a lot more heat, and you might end up. It's a bit difficult to do, but you might end up destroying the component. So I recommend applying a lot more soldering paste, this solder wire, when trying to remove the SMD components.
I think I'll have all of the actuators ready, cleaned within an hour, I think. So like as soon as we have the bearings and the brass inserts, the encoders are also ready. It'll just be quick wiring and we can have all of the actuators ready to assemble. Aside from the actuators, all of the
body parts, the arms, the legs, they're also printed. We have the aluminum profiles.
Look at this small thing over here. This tiny component.
I think this was the cleanest video we've got of it so far.
Huh?
It focused really well.
Let's
Yeah.
keep going. Keep going.
So I think if we have once we have the brass inserts and the bearings, the actuators are pretty much ready to start assembling. The encoders are ready, which we thought would take a lot of time, but it just took us 1 hour or 1.5 hour. We have the aluminum profiles. I think we can assemble all of this pretty quick.
Yeah, it's not gonna take long, and that's why we have this optimistic timeline of 1 week to assemble this
Yeah.
whole robot. Because once we have all of these components ready, it's not gonna be like a lot of work to
It's just gonna be some wiring
yeah.
and some screws and joints.
Yeah,
So like,
because the bulk of the time, except for shipping, like the shipping isn't, I would say,
it's the most time. In this
one of
most of the
one,
time
one
in this
of the
project
one
went.
of the two. The second one is like 3D printing.
3D printing also
Yeah,
took a lot of time.
if your project involves 3D printing, it's gonna that's
But the funny thing is, shipping took far longer than 3D printing.
Yeah,
So like the
yeah,
3D
yeah,
printing was
that's the thing.
finished quite early on because we just started right away. But shipping all of the parts, it's not even resolved till now. It's like we still don't have all of the parts.
yeah. Okay, this one also looks good to go. Let's put it over here. We have very few ones left. Let's put it in there. And we're gonna unbox a bunch of others as well. Let's remove this. And I'm gonna try to be quick with them this time around. Imagine if after soldering all of these components I realized that I've been soldering the wrong resistors and we have to like move back and do it all over again.
We're probably doing the correct one. Probably.
Probably. That's a dangerous word in this situation.
Okay. On this, on the alright, on the hardware end, in parallel, we have one more actuator part ready for assembly. As soon as we have the bearings, the brass T-nuts, the screws, all of the required components, we'll assemble this with the motor driver, the motor, and these encoders, the ones that we're soldering right now. So this is also finished. There's 22 actuators in total, and I'm working on others as well. Okay, where's the next one? Here we go.
I think you can join them over here, like
No. Keep the station to yourself. Because this is quite a precise job. We'll have these tomorrow
so
probably.
Yeah, tomorrow probably, once we're wiring and assembling all of this together, once we have screws and everything.
Yeah. Let me go ahead. You can turn this off now. Just remove the wire from this holder.
Okay. Right.
Yeah, it's gonna be a crazy spectacle for the internet, like removing SMD components by using two solders at a time. When we started this video, but every day you learn something new. There's a first time for everything.
Yep. The deadline for this project is we have quite an optimistic deadline for it. We hope to finish it within 1 week. And the funny thing about setting really optimistic deadlines like this is that one way or the other you do tend to meet the deadline. And if the deadline is too loose, it's too relaxed, you don't have that kind of motivation to finish the project, and it's just unnecessary delays. Most likely it will be finished before the deadline. This part is good, it's done. Moving on to the next one.
Once again, this is the SMD component we're soldering right now. Yeah, if the phone can focus on my finger, this small component is what we are soldering on these encoders. So we have to desolder them first, and we have to resolder them again, but in a slightly different orientation. And what helps the most in terms of removing and attaching these components again is the application of solder wire. So the more solder wire you apply onto the board, the easier it's gonna be to get the SMD component in its rightful place. Also, before removing the SMD components, if you don't apply the solder wire, it's gonna be really difficult for you to remove the SMD component. You can try applying all the heat in the world if you have like a small 15-20 watt soldering iron, but the SMD component it's gonna be really difficult to get it to move. But if you even add a small amount of solder wire around on the two ends of the SMD component, it's a really good conductor of heat compared to the tip of the soldering iron. You're gonna be able to move the SMD component instantaneously. Okay, let's have a look. This one looks good as well. Let's add it to the collection over here. Move on to the next one. Yep, this is our one. The thing with building robots, and especially building humanoid robot like this, is you have to kind of learn in small segments all of these various fields that surround this robot. For example, you have to learn software, definitely you have to learn hardware. In hardware, I'm talking in terms of design, like 3D CADing, product design a little bit if you're into it. If you want your robots to look really flashy, really good, you have to learn that as well. Then modeling or CADing in CADing software, or if you're into more artistic fields, you can also do it on Blender. I really like Blender. Blender is like my favorite 3D software, but the learning curve in Blender is really huge. If you're trying to just brute force your way in terms of learning Blender, it's gonna mess up your head really quick. But if you're a creative person, if you love drawing, making illustrations, or other forms of art, you're gonna really love Blender. I absolutely recommend learning it. But you can make robotic designs on Blender as well. And then the next field in terms of robotics is embedded and messing with electronics like this. It really helps if you know what you're doing with these components or with the circuits that you're working on. So when you're working on robotics, you kind of get a bird's eye view of all of these different fields.
The thing about learning is though is that it all compounds, and that's a really good thing, but you have to stick with one field only. So like if you keep jumping around from field to field, your knowledge of that field is gonna stay pretty shallow over the years, and you'll have a shallow knowledge across various domains, but you'll not have very deep knowledge in any one of the fields. But if you stick with one field, the knowledge really compounds, and it compounds really fast. For example, the thing that we're doing right now, SMD soldering or things like that, they might be new for us today, but in 6 months or 1 year's time, it's going to be basic thing, and will be done with it, and will be taking on bigger challenges. So the thing with learning is if you keep doing projects, it really does compound over time. So at the start it might seem like coding, CADing, all of these things are pretty difficult, but it compounds really fast. So like yeah, that's a good thing about learning.
We're almost done with these components. This component just used the instant transmission. It just disappeared from here and appeared over here.
Huh?
Yeah, like it flew off the tweezer, but that's like what it looked like. But we're almost done through with these components and encoders. So after that, we're gonna be hooking these encoders up with the motor controllers. Yep, so it's it in its rightful place. Let me add some more solder over here. But yeah, these are turning out pretty nice for from how intimidating it looks. It's really simple to do. Like I mentioned earlier in the video, just remember two things. One is you have to apply, if you're like removing SMD components by using a simple soldering iron, you have to apply a lot of soldering wire in order to get this component to move. And then you just have to be really precise with grabbing these components, moving them around, because if God forbid they fly away from your tweezer, or if you drop them, Well, it's a long night looking for them. It's gonna be a long night. As Donald Trump says, it's gonna be a long night, my friends. That was not the best impression of this guy, but he talks like that. Yeah, now that I'm looking at the audio levels in the streaming software, we're definitely gonna have some troubles with the audio in this video, but we're gonna get them fixed by next live stream. Okay, let's move the other resistor as well. I think we should name these live streams something like you know, those lo-fi live streams, chill and work,
Oh yeah,
something
Yeah.
like that.
yeah, good idea.
Something that people can work on their own projects while listening to our live stream or looking at our live stream,
Yeah,
like
because
a
I think
joint
Yeah.
workshop sort of session or a co-working space, that kind of vibe.
because I think this is gonna be an ongoing thing, and we can use that sort of a brand, that sort of the niche. It's going to be an ongoing thing. We're almost working every day, and this setup is pretty neat and
Yeah.
relaxed. Yeah, we're always working
Yeah.
like this.
We just need to add a bit of more scenes, like maybe a camera angle of us when we're talking, looking at the camera, and we just maybe we need to make a, what do you call it, a very modest or small
Studio.
yeah, live streaming sort of studio. We have some robots in our lab that we built right now. Maybe place them behind us, and we need to make a few different scenes to switch to when we're talking to directly to the camera or when we're working on the components. Yep. Wow,
This is pretty
one
fun,
is-
by the way. It's
yeah.
our first live stream that we're doing, but this is pretty
Yeah.
fun.
This one turned out so good.
Nice.
Omoshiroi ne.
Yeah. Yes, it's
And-
not
and
short either.
Is like
really
any one
good.
of you guys interested in Mandarin language? Those Mandarin languages are so difficult and they're like so complicated. I'm really interested in the origin of these languages. Like, what was the guy who came up with the writing system for these language thinking? What was going through his head when he decided, okay, I want 3,000, 5,000, 6,000 characters, written characters for my language? What was the dude thinking? I'm really interested. I don't know about the history behind that, but I'm really interested in knowing that. So yeah, the Japanese is one of the top 3 or top 5, including the Chinese. It's one of the top 3 to top 5 most difficult languages in the world, mainly because of its writing system. It's the same for Chinese, and for people from Japanese background or a Western background, like people for whose first language is, let's say, English. Arabic is really difficult to learn for them as well, especially like in Arabic, grammar wise, tenses, and just the basic structure of the language as well. It's really difficult to learn. It's one of the most difficult languages. Compared to that, Espanol, Spanish languages, Italian, those languages are easier to learn. The languages with the writing system, where by the writing system is in English, that's like those are already really easy because of you can just read what's written, I guess, on the papers, web, and stuff like that. Let's put it in there as well. But yeah, Mandarin languages, I wonder what's the history behind them. I'm gonna have a look at it after this. Yes, the most useful thing in our soldering station, which was the double-sided tape that was holding these things together, it has started to give up on us. So I'm gonna take a bit more double-sided tape in a minute, and I'm gonna place it on the table.
The mechanical parts are also coming along pretty good. I know it's not in the view. The view is only showing the electronics aspect, but the work is also going on the mechanical side. The 3D printed parts for actuators. I am just cleaning supports from them.
Yeah, so we're running in that problem again. It's getting a bit difficult for me to remove this SMD component because, like I told you, we need to apply a lot of solder wire to both ends for the heat to better make its way to these components. So now I've added a lot of solder on both sides of these components, and let's wait for it to solidify a bit, and then I'm gonna move on and remove it. Let me make sure I can grab it by using the tweezer. Yeah, this double-sided tape has really, it's really protesting right now. Like it wants out. It wants no more part in this business. It says I'm done.
Alright, one more actuator done. I'll just grab another one now. And this part, loose thread over here. Over here, over here. This one goes inside, inside, and
Grab this and
alright. One more actuator done, by the way.
Yeah, this part was getting a bit difficult to solder. As you can see, I applied a slightly more solder than I needed to, and it was getting closer to this capacitor over here. I'm gonna have to remove a bit of solder from here as well. Let's try and not mess it up this time. I'm gonna remove some solder from here. There we go. It's looking clean now. Another one done. We have to make sure afterwards that none of these are short in the wrong way, in the wrong order. But first I'm gonna go ahead and finish the rest of them. Yeah, this double-sided tape has its day. We're gonna replace that. I'm gonna so yeah, normally you can get SMD soldering station that takes a that can cost a bit of money, but there are other small soldering stations with magnifying glass that you can use to solder SMD components, and there are also tweezers sort of suspended in air on those platforms. You can get them for really cheap. You can get them for like 100 yen or something like that, and they make it really easy to hold these components. Like right now I'm doing this by using a double-sided tape, and it's not the most efficient thing in the world, but if you use one of those soldering stands with magnifying glass, I'm sure it becomes a lot easier, and they're not that expensive. Like I mentioned, it only costs like 100 yen.
Yeah, there's a really professional way of doing something, and then there's a hacker way of doing something. And right now we're going the hacker way.
Yeah.
Right now, and it's working pretty well. Like all of the parts almost came out perfect, almost perfect. I don't think we'll have any problem connecting the motor drivers and programming the encoders.
Yeah, fingers crossed.
I really do hope the parts arrive quickly.
Yep. When we're building something like this, pretty much most of the components are almost always from China. China has like really uh, made its space in the manufacturing space to the point where no other country can even come close in terms of manufacturing.
Yeah, their manufacturing pace is so fast. They have pretty much all of the tools or machinery in their locale, in their neighborhood,
Yeah.
to produce everything. And so like the lead time is really low for manufacturing.
Yep. And I've never been to China, but I've looked into their manufacturing stuff, how they're able to produce so much, and it's really efficient. And it has taken them many years to build it up to that point. That's why at the if pretty much any other country wants to even compete with them, it's gonna be almost impossible task to do it in a short amount of time, because what China has going on with their manufacturing industries over there,
they are all really highly specialized, and they are all in the same locality. So if any other country wants to achieve that kind of efficiency, it's gonna take a lot of planning, of course, and then many years to build that sort of infrastructure.
Many years, especially many years of sticking with their planning, because
Yeah.
like in most countries the policies just keep changing with different leaders,
Yeah.
different people coming, the policies
Also,
keep
a big
changing.
benefit China has, of course, is because most of the businesses, like the most high tech sort of businesses, there are state owned or state sponsored. But in like USA, let's say for example, most companies and businesses are private. They have their private interests, uh, and even if they are collaborating with other companies or industries, there are a lot of contracts or legal documents they have to sign to get that stuff moving. The overall process is really slow as well. Whereas in China, if the government wants the country to work on a really specialized field, they just have a lot of companies under their belt that they can just connect together. They can put all the pieces in place and they can just get everything running, and most of it is in the same locality. That's what makes the process really fast and efficient. uh, it's where all the manufacturers can sit together, talk with each other on daily basis. It's like the UFO, what UFO table did in anime, you know. Most of the anime that's produced these days, there are a lot of companies or individuals working on an anime, and most of the time, almost for all the studios, it's a lot of it is done remotely. Like, you know, uh, you have a lead animator who makes all the keyframes, and then you outsource it to someone maybe in Korea. Maybe a lot of times it's outsourced to freelancers that are living around the world. So it's really difficult to collaborate together on a really well-made anime scene. Whereas when it comes to Ufotable, the reason they are able to make these really sick animations every damn time uh, is because they have their entire team in-house. So everything from their hand-drawn animations, their in-between animators, to their CGI team, to the video editing team, to the post-production team, everyone is in the same building. So they're able to really talk it out, discuss what scene they're gonna be building, and then they build all of that stuff in parallel together with each other. And that's the reason you call them unlimited budget works, because they really make a spectacle out of every anime they work on, and that's how they are able to achieve that much efficiency. It's the same thing for um, China when it comes to how they're able to build such incredible hardware at such high pace. It's because they're all working, most of them are working under the government, most of them are subsidized by the government, and they're all working in the same locality, working on the same things. It's really difficult to achieve that kind of cohesion anywhere else around the world, especially in really capitalist markets like USA, where everything is about capitalism and everything is about individual companies, private firms.
China is pretty good across the domain, so across all domains. So in terms of power,
electricity, infrastructure, even software, AI, like when they created DeepSeek, robotics, hardware manufacture. Like they're pretty good across all the domains, across different domains. And I haven't looked much into it, but they also do have pretty good geopolitics commentators or journalists, people as well. It's a pretty fascinating country across all domains.
Especially on my channel, I make a lot of generative AI stuff, video generation models, image generation models, and the best open source models out there. As you guys already know, video generation model, they are from China.
Yeah.
You know, it's really amazing to see how Western companies like OpenAI, they throw billions at a problem, and then China,
Just some random developer comes along. Some random developer.
random unnamed company comes along,
Yeah.
obviously backed by the government, hush hush, but just random nobody company, and it's able to make such a amazing product at a fraction of the cost.
Alright. And this these parts for this specific actuator, they're not, let's just say, the best results that could come from 3D printing. So like once we have connected the motor, encoder, everything, we'll need to see if this one is working perfectly fine, or we need to reprint this one again. We can't really say unless we have the bearings and all of the parts to assemble this. So we can't really test till then.
There are only 3 left on this side, so I guess we're gonna assemble the the remaining 3. Then I'm gonna do a continuity test on these to make sure everything is correct. All the soldering we've done so far, it's in the right order. Once we make sure of that, we're gonna go a bit over the what we're gonna hardware wise, what we're gonna be assembling in the next video, the next live stream, and then I guess we can call it a day for today.
Yeah, okay, this one is a bit good. I'm really hungry. I think I'm gonna grab a bite after these encoders are complete. And I have 1, 2, 3, 4 more sets of 3D printed parts to remove supports from and clean. I'll just arrange them on this the table somewhere, and after that, yeah, we can call it a day maybe.
Oh,
There's
man.
some other tasks. Yeah, everything good?
Yeah, I just lost one resistor and I have no idea where it flew off to.
Oh.
Absolutely no clue.
Was it the 102 or was it the
No,
01?
that was let it's
If it was 102,
not
we can
here.
like-
Yeah, it's right here.
Oh.
So it just disappeared
and then it appeared over here. If you're able to see this, yeah, never lose your SMD components. Like if it fell somewhere on the floor, it was gonna be like impossible for me to find it. These parts are good, these parts are good. Let's place it over here. Okay, this one also good, these two also. Alright, this part is also done. Just place this here, inside of here, this one also here, and last two parts here. This actuator is also finished. Pick this up and place it over somewhere over here. I'm gonna grab this and let's attach this.
2, 3,
Let's try
4,
not to
5,
mess
6,
it up
7, 8, and
again.
2. So like these are all complete for the arms. Let me just quickly gather all of this support that I have removed. Gather all of the supports.
Another one done. Second last one.
I'll just quickly grab something to eat. I think we don't have enough water as well. I'll go visit a company.
Okay.
Do you need something?
Yeah. No, I'm gonna head there by myself after that. To this. So I'm gonna be like making. There are 2 more encoders to go, and after that, I'm gonna check them for continuity, and I'm gonna like end the video after these 2 encoders.
Yeah, we can wrap this up at this point. There's really not much we can do without the bearings and the screws and inserts.
Okay, so I have these 2 more to go, and these are ready. I'm gonna do a continuity test on them in a bit. But regarding the actuators and the joints of the robot, we don't have all the bearings yet, so we cannot start working on them yet, but most probably tomorrow we're gonna be doing another live stream and we're gonna be working on these. So yeah, looking forward to it. And once we have all of these ready, we're gonna be able to assemble our robot over here. Hopefully it's gonna take 1 week to assemble this whole thing from top to bottom. And yeah, the encoders are done. We're gonna have the motor drivers tomorrow, and the bearings and all the materials to put this stuff together. So yeah, tune in for that as well, and let's build this thing together. Alright, that's gonna be a wrap for this live stream. I'm really hungry. I'm gonna grab something to eat as well.
Cheers, everyone. Thanks for tuning in.
Thanks for tuning in. Really appreciate your time. And if you have any questions, or if you have any, if you want to know anything more about this robot, let me know in the comment section down below. And yeah, see you in the next one. Cheers.